Let's start by examining our quadratic equation x squared plus 5x minus 1 equals 0. This is an example of a second-degree polynomial equation that we need to solve. To solve this equation systematically, we need to identify how it relates to the standard form of a quadratic equation. The standard form is written as x squared plus bx plus c equals 0, where a, b, and c are numerical coefficients. Let's identify the coefficients in our equation by color-coding each term. This will help us clearly see which number corresponds to which coefficient in the standard form. Looking at our equation, we can now determine the exact values of our coefficients. For the term x squared, the coefficient a is 1 because the term is simply x squared with no other number multiplying it. When no number is written, we understand that the coefficient is 1. For the middle term, plus 5x, the coefficient b is 5. This is directly visible in our equation. And for the constant term, minus 1, the coefficient c is negative 1. Notice how the sign is included as part of the coefficient. Now that we've identified all three coefficients, a equals 1, b equals 5, and c equals negative 1, we have everything we need to apply the quadratic formula. These values will be substituted into the formula to find the solutions to our original equation. Now that we've identified our quadratic equation x squared plus 5x minus 1 equals 0, we've substituted our values into the quadratic formula. Here a equals 1, b equals 5, and c equals negative 1. The expression under the square root is called the discriminant. It's written as b squared minus 4ac. This part of the formula is crucial because it tells us how many solutions our quadratic equation will have. Let's calculate the discriminant step by step for our equation x squared plus 5x minus 1 equals 0. First, we substitute our values from the original equation. Since b equals 5, a equals 1, and c equals negative 1, we get 5 squared minus 4 times 1 times negative 1. We start by calculating 5 squared, which equals 25. This is the first term of our discriminant. For the second term, we multiply 4 times 1 times negative 1. The 1 doesn't change the value, so we're essentially multiplying 4 by negative 1, giving us negative 4. Now we need to subtract negative 4 from 25. Remember that subtracting a negative number is the same as adding its positive value, so 25 minus negative 4 becomes 25 plus 4. Adding 25 and 4 gives us 29 as our final discriminant value. This is the number that will determine how many real